Okay, dividing rational numbers, there's a little bit more to it. We have what's called rationalizing the denominator, meaning we can never have an irrational number left in the denominator, so we always have to rationalize it. And I'm going to show you 3 different methods, but this is, I'll start with this, what I think is the easiest way. Now notice right away you could take the square root of 16 as 4, but I'm going to show you a little tip. The square root of 16 is root 4 times root 4, and the square root of 12 we can rewrite as root 4 times root 3, and then look at those root 4's cancel, and then the only thing we have left is to rationalize that root 3, and to rationalize it, you're just going to, so if we had a root 3 right here, you're just going to multiply the numerator and denominator by root 3, because remember, root 3 times root 3 will equal 3. So that's what we're doing in this next step. We're multiplying the numerator and denominator. Well, notice root 4 is 2. So then when we multiply the numerator and denominator by root 3, there we have it. Oops, I'll put this on pause. Okay, I don't know where I was mid-sentence, but this is, I think, the simplest way. The next way that you could do it is you could simplify the square root of 16 first. Then you've got 4 over root 12, and then break down, multiply top and bottom by root 12. And then you've got 4 root 12 over 12, and then notice that will cancel to 3. And then 12 can be simplified to root 4 times root 3. The 4 cancels to 2, and that leaves you with this. So there's method. And then finally, right away, you could simplify this whole thing by saying square root of 16 is 4, and the square root of 12 is root 4 times root 3. Simplify that. Square root of 4 is 2, and then 4 divided 2 is 2. So then you end up with 4 over 2 root 3, which simplifies to 2 over root 3, and then you multiply top and bottom by root 3. So whichever method there is easiest. Then when you have a binomial in the numerator, now you can't just simplify this and if something cancels, because that's an expression and everything would need to have the same thing before it would cancel. So my suggestion here is break down the root 20 to 4 times 5, and the square root of 4 is 2, and then 4 times 2 is 8. So you have 8 root 5, and then multiply the numerator and denominator by root 5. When you do that, you've got a distributive, so it's negative 3 root 5 plus root 3 times root 5 over 8 times 5, which is 40. And root 3 times root 5 is root 15. So there's your simplified answer. When you have a binomial divided by a binomial, you're going to use the conjugate method. And I think, did I write that there? And remember, the conjugate method is when you take, if you have two things, the conjugate would be, the operator in the second expression would be the opposite operator. So it would be 4 subtract root 3. So you multiply top and bottom, and then remember with conjugates, you multiply the first times the first, and then the second times the second. Remember, a positive times a negative sign would be, or subtract sign would be between the two. So 4 times 4 is 16, root 3 times root 3 is 3, and a positive times a negative is a negative, and then 16 subtract 3 is 13. In the numerator, you have root 2 times 4 and root 2 times 3. So 4 root 2 and 4. Oh, okay. I see what I did here. I did the distributive with these two. I did 4 times root 2, 4 times root 6. You could do it either way. And then negative root 3 times positive root 2 is negative root 6. And negative root 3 times negative root 6 is negative root 18. And then simplify root 18 to 9 times 2. And then the square root of 9. Let me cover up some of this stuff now. So when this was negative root 18, it simplifies to this. The square root of 9 is 3. Now look at, we have some radical expressions that are same. There's 4 root 6 and subtract 1 root 6. And now we're going to have 4 root 2 subtract 3 root 2. So I went ahead and combined these right here. And now we have 4 root 2 subtract 3 root 2. It simplifies to this. And I think that's it for this one.